Okay, welcome back to the statics class. Let's first revise what we have done on Tuesday. On Tuesday, we first discussed equilibrium. We discussed equilibrium. Equilibrium is essentially Newton's first law. You must know this. And verbally, in words, it is defined like this, that the resultant force equals to 0. In mathematical expression, if you write it in mathematics, it means summation of F equal to 0. And in graphic expression, it means all the forces, if we put them together, link them one by one, that it has a closed polygon. When we solve problems involving equilibrium, we must first draw a free body diagram. I will show you. It shows all external forces acting on a particle or body, and all other. To give you a hint, that because your seniors usually miss some of them because they miss some of the forces and could not solve the problem correctly. So to give you a hint, all other bodies in contact with a body, that means, for example, the floor, the floor is in contact with the 2 feet. So there are reaction forces acting on the body. To give you an example, let's work on a sample problem in the textbook.
老师，你是不是没有分享荧幕？
Thank you. Good. Sorry. Thank you. And so we work on a sample problem here, 2.6. As so we have any words that you don't understand or you don't know, can you type it? If you can, for those who have the text, who have the chat box, can you type them? Of course, I've put the translation of these 2 words, but I think you have some words that you don't know well, I think. Anybody? Or you? Of course, you can turn on the microphone and speak it out. Or you know all the words in this question. I think I've told you to. I've told you I will talk about this today, right? So, anybody? Dynamic, good. I'll explain this. Good. Are there others? Nope. Okay. Good. So drag force. Good. Yeah, these 2 are the 2 words in green are quite specific in mechanical engineering. Good. And are there so you may type it when I go on, right? You may type it when I go on. This drag force means this one. And dynamometer is There are different equipment to measure force in this, for cars and for boats and for airplanes. For things that move, we usually use a dynamometer. The test channel is good. Test channel. In this problem, it is you can translate it as this one. Of course, in airplanes we have when we test airplanes, we have for airplanes we have air tunnels. Air tunnel. Wind tunnel, sorry. And for ships and boats we have, okay. This one is to this one. Are there any so you can type it when I go out, okay? So as part of the design new sailboats, we want to. So we have we are putting we have flowing water here. We have flowing water here, and we want to determine the drag force. We want to determine the drag force, because if we have high drag force, that the boats cannot go fast enough, right? So we measure. We have water flowing from the left to right, and we want to measure. We are measuring the tension in these three cables, and because it experienced drag force, so we want to measure that drag force. As long as it is not moving, that it is not moving, that it is in equilibrium. It is not moving, so it is in equilibrium. Let's go on and solve. The problem gives cable AB has tension is 200 Newton, and cable AE has a tension of 300 Newton. But we have some unknowns. What do we want to determine? We want to determine one, the drag force exerted on the hull, the drag force, this one. And two, we want to determine the tension in cable AC. We want to determine the tension here. Therefore, first of all, how many forces? First, we draw a free body diagram. We draw a free body diagram, or we take a look at the problem. How many forces are here in this problem? How many forces are here in the problem? Can someone put it in the discussion box, or say it? You can say in Chinese or in English, of course. Some of you say 4. Any other answers? Good. Be careful that we have 4 forces. We have 4 forces. We have the tensions. We have three cables. So we have the tension of cable AB. We have the tension of cable AC, and we have the tension of cable AE. But besides these 3 forces, we still have 1 force. Sorry, and wait a minute. So beside, on top of these force, these 3 forces, 6. Some of you say 6. I will. I think there are not that many. Let's try it out. We have three cables, so we have 3 forces. But on top of these 3 forces, we have remember we have that the boat or point A we experience drag force, and of course because the water is flowing this way, so the drag force is in this direction. Is okay. So for I think that is all. We don't do we have some forces missing? If you think so, you can say it or you can type it in the box.
重力还有浮力。
Okay, good. Good. You mentioned these 2 forces, and I think we don't need to consider these forces because gravity. Wait a minute. Very good. You know what I am writing? It's, so this goes up and this goes down, and for these 2, I don't think we need to include these 2 because we are dealing with you can say we are dealing with x and y directions only, because these 2 are in z direction, and I think let's put them one side. Let's put them one side, and we only deal with these 4 forces. Okay. But very good answer. Very good answer. Thank you. Before we go on before we do the calculations, let me first write. So we have 4 forces, and this FD be the drag force. In the past, of course, I give you 4 forces here, but in past examinations, your seniors usually miss one of them and they only write 3. Some of them. The next, we draw a free body diagram. You can draw it on one side, but it has to be separate. Okay, it must be separate. So we have 4 forces, and let us put x and y here. X and y here, and I usually use 2 colors, and it depends whether you like using 1 color or 2 colors. So we have 4 forces. First of all is TAB, because we know the magnitude, and we write it down as well. TAB equals to 200 Newton. Oops. And this is y. And this angle is alpha. The second force is TAC. We don't know its magnitude, but we know its direction or its line of action. Thirdly, we know we draw TAE going down. Please draw with me, and if you don't have your notes with you, find a piece of paper and draw it on the paper. Draw it with me, and I will leave you time to draw it. TAE, 300 newtons. And for the last one is drag force here. Oops. FD, of course, is towards the right. How can I get it right? Okay. So we have 4 forces, and you need to mark the direction of all forces and any angles or any magnitudes that you know. Of course, for some of them, of course, we don't know how large is the magnitude of TAC, and we don't know the magnitude of FD either. But at least we know the other 2, so we need to write them down. If you have finished drawing it, please raise your hand. For the others, I will give. I will wait until at least 2/3 or 3/4 of the class have finished. So I'll give you time. It's very important to draw figures right. As I've said, if a question has 10 points or 10 marks, the figure will count at least 3. Is that okay? So always draw figures if it has equilibrium. If you have got your notes, draw it on your notes. If you don't have your notes, draw it on any piece of paper. Are the others okay, or do you want me to repeat anything? Because I see some of you are still drawing. So the other I see 56 hands, and are the others okay, or are you? So give me other symbols if you around, but you want some more time. If you are in front of computer but you want some more time, give me another symbol, or you can type something on the discussion box. So assume those who have not raised their hands, are in away from the screen or in the toilet or somewhere else. I assume. So I assume most of you are okay. So if you want to check something later on, check the graph later on, you can always watch the video. Next, so we go on. Next, you can put down your hands. Thank you. Next, we work on we start doing the calculations. Before doing calculations, do one thing, please. You can write the words, but you can skip the words, but you always need to write the equation. You can say because of equilibrium, we have this equation. We have this expression. We have this equation. Okay. Always write this equation. Of course, sometimes questions in examinations can be difficult. It can be difficult, and you don't know what to do. You don't know how to work on the what. You don't know how to work on. You don't know how to work on it. But at least you know. If you know this problem is about equilibrium. If you know this problem is about equilibrium, write this expression down, and at least you can get some marks. Especially you are too worried about whether you will pass the course or whether you pass the course or you how many marks you will get in an exam. At least you write this and you get like 10% or so, and let's okay. Is that okay? Write this down, and because we have more than two forces, or we have more than 3 forces, we cannot use trigonometry alone to solve the problem. Therefore, we are prepare this table. We prepare this table, and from the figure that we can always know alpha and beta. This I think you can handle. I think you can handle this. I mean, handle is. I think you can handle this. I don't think you have problem with this. Next, and then we go on to preparing the table, and we know two of the forces. We know two of the forces, and we don't know the two others. So magnitude, we know one of them is 200 newtons, one of them is 300. We don't know TAC, and we don't know FD either. And for the angle, remember where is 0 degrees? 0 degrees is horizontal to the right, and then this one is from 0 to 90, and go on. Therefore, we have the angle should be like this, and this one is 69.44, and that's 270, and this is 0 degrees. I assume you can handle this. Therefore, and because we have equilibrium, we add them together. That the magnitudes must be 0, and as in the last sample problem, we have fx equals to f cosine theta and fy equals to f sine theta. And to give you an example, we have we have this one equals to 0.3512 TAC, and this one equals to 0.9363 TAC. I think you can fill in all these boxes, right? And this one is equal to FD, and this one is equal to 0. If you have the textbook that it is on the textbook, if it's not on the textbook, you can still fill in all these boxes. I think you can handle this, right? So because when all forces added together is equal to 0, so you have this. Next, please go home. When after the class, can you fill in all these blanks? Fill all these blanks. Fill in the blanks means this one. Go when after the class you go. You can fill in the blanks. I mentioned if we have problems involving equilibrium, you must write summation f equal to 0. Summation f equal to 0. And after you draw this, after you prepare this table, of course we have two equations, and you are very happy and write these two equations. But please do one thing. Write these two down. Because the first equation comes with is related to the x direction, and the second equation is due to the equilibrium in y direction. This first one is about the x direction, and the second one is about the y direction. So please write these two. Please write this. Because if you do everything correctly, then I know what you are doing. I know what you are doing. But if you get some of these things wrong, at least if you write this, I know you are talking about this. But if you get the numbers wrong and you don't, if I don't see this, then I just wonder what are these. And if I miss something, that you miss the mark. Okay. So after this, of course, we can get the answers, which are TAC equals to 214.45 Newton and FD equals to 98.35 Newton towards the right. These are the answers. I want to so for let me make it when you're writing, let me make a quick remark. For these two equations, I write 0 FD here. Why I'm doing this? Why am I doing this? Because this is we have two unknowns and we have two equations. Of course, you can use the techniques in the junior high school to solve them. But another way is to make use of your calculator. In calculator, we have different modes. Then I think for my calculator, that we have different modes, and if for example we have equation mode 5 is EQN, which is solving equations, and we have mode 1, 2, 3, 4, and 3 and 4 are for quadratic and cubic equations, which are
老师，你的麦克风是静音的。
Okay, good.
没有
Can you hear me?
声音啊。
Can you hear me now?
现在有了。
Good. And so we have but we have 2 variables and 3 variables up here. And if you press, for example, press 1, and then you can solve these equations quickly. Is that okay? So go to see the user manual, or go to YouTube to and see how others use the calculator. Of course, you can use those techniques you learn in junior high school, but I'm just letting you know that if you want to make less mistakes, that make good use of your calculator, it can help you. Okay. Are there any problems with the calculations? The key point is not the calculation. The key point is that you please, 1, draw the free body diagram, and 2, do your, write things clearly. I mean this one and this one. Write things clear. I mean this one and this one. Is that okay? If you know the key points, please raise your hand. As I always say, I'm not worried about your mathematics. I know you can handle that. But the key point is firstly, the free body diagram. Secondly, please write this down when you do your calculations. Okay. So before we end today's class, because we have like 10 minutes, before I repeat the key points, let's go to 3D space. I think I don't have time to explain everything here. I will show you, and I think it's better for me to show you something on the live on the Tuesday. But let's do one thing. How can we draw 3D graphs, or how do we draw 3D objects on 2D plane? It sounds simple, but it is not. Actually, in computer games you play every day, unless you have 3D monitor, that the computer is doing this every second. Okay, computer games always do this because you have 3D figures, but it's shown on a 2D screen, 2D monitor. And in engineering, and we have 3D objects, we have 3D products or 3D machines, but we need to draw them on the paper. So we have two. This is in engineering, we call it projection. We have 2 ways of doing this. Please draw with me as well. We have 2 ways. One is called isometric, and another one is called oblique. This one is pronounced. Wait a minute. This one is pronounced K. Oblique. Isometric. ME isometric. This is. Sorry. Okay. This one is Q. Okay. You can put down your hands. Thank you. Let's do some drawing. Let's we have in 3D space, we have X, Y, Z axis, right? We have X, Y, Z axis. We want to draw then in isometric drawing, we have we put 3 axes here. Each of them is like 120 degrees. Okay, roughly. And x, y, z goes x, y, z go this way. Of course, if you want to draw it beautifully and you take some time, that you can find another piece of paper and do a rough sketch. Do a rough sketch first, and then we for each unit, for each unit, we do it the distance. The distance is the same for all axes. Okay, the distance for all axes are the same. This one is equal to this one. This one is equal to this one. All 3 are the same. So if we want to draw a column of 1 times 1 times 2 units, we draw it like this. 1 times 2 times 1. Let's say. Oh, sorry. Like this. Not very well. It's vertical. Okay. So this is 1 unit, and this is 1 unit, and this is 2 units. Is that okay? After you have drawn it, and if you're done with this, that please raise your hand. Take your time. I'll give you time. In the textbook, figures are always drawn in one of these 2 ways. In this textbook, of course, in the next semester, you have a course called engineering drawing, and it will be drawn differently. But in this course, in statics, they are all drawn this way. I think. Probably let me stop here and let me go through